These are notes on food webs, and they're on pages 383 to 388 in your text. And I recommend just kind of glancing through that, just in case there's some information that you didn't have before, just so you can be aware of what all is in there. So here is a basic food web that I found on the internet, and I thought was cute, but also actually shows everything we need it to show. So a food web consists of different organisms. Some are the eaters, some are the eaten, and so the arrows always go from the thing that is being eaten to the thing that is eating it. So the pink bunny eats the plants. The eagle eats the pink bunny with this arrow. And one of the ways you can think of it is that the plants go into the bunny and the bunny goes into the eagle, and so that's a good way to remember it. What it's actually doing scientifically is it's tracing the flow of energy in an ecosystem. So energy from the plants flows to the bunny, which flows to the eagle. And later when we talk about trophic levels, we'll see that that's following the flow of energy as well. So we're very concerned about flows of energy in biology. All right, so down here we have our producers, which, as you remember from your notes on living organisms, those are autotrophs, meaning they are making their own food. So they're using energy from the sunlight to convert carbon dioxide and water into sugars, which, anyway, we'll get into more details about that later. But they're making their own food, auto meaning self, doing it themselves. And then everything else is a consumer, or a heterotroph. And hetero meaning other, so these organisms are getting food not by themselves, they're getting it from something else. And again, we saw these words autotrophs and heterotrophs in the notes on living organisms. Most of the autotrophs you're going to find in a food web are going to be photosynthetic versus chemosynthetic. Certainly if you had like a cave biome, you may have some chemosynthetic producers, but generally in a lot of the biomes we're going to think about, we're going to have photosynthetic producers. So that could be algae in a marine environment, that could be plants in most land environments, and then there are a few like cave biomes where the producers are chemosynthetic. So let's talk in general, or let's talk about some new vocabulary. So one of them is a specialist. A specialist eats only one type or very few types of organisms. So looking at this food web, and you can pause the video in a second, see if you can identify some specialists. So if you said, for example, the lizard-like iguana, I don't know what it's supposed to be here, that would be a specialist because it only eats this caterpillar. So you can see if anything were to happen to that caterpillar, that's going to be a pretty big deal for the iguana because it has evolved to eat this caterpillar or larva or whatever the heck it is. And so without that, that's going to be a big deal to the iguana. Some of you may have said like the snail or the worm or even the rabbit, but if you'll notice there's lots of different kinds of plants down here, so those probably aren't specialists because they can eat lots of plants. And anybody who has a garden knows snails are absolutely not picky eaters. They will eat any green matter that they happen to come across. The opposite of a specialist then is a generalist. A generalist eats a varied diet. So, for example, the eagle here is a generalist. It eats these iguanas, it eats these fun little blue birds, it eats pink bunny rabbits. And so I wouldn't say it's hardier, but it has more options. If suddenly it realizes that pink bunny rabbits don't actually exist in the world, not a problem. It still has these weird little bluebirds and the iguanas to eat. So it has a much more varied diet. It's a little more flexible in what it eats. All right, so now let's talk about trophic levels. sorry, there we go, trophic levels. So we've already come across this word troph, right? We've seen autotroph here, making their own food, heterotroph here, getting food from other things. So you've possibly figured out that troph has something to do with food. It comes from a Greek word, and it does, in fact, mean like pertaining to food. So when we're talking about trophic levels, we're talking about food levels. And any food web, any good food web, should be organized along trophic levels. Okay? So what you have down here, again, we have the producers. Okay? Those are on the bottom of what we would call a trophic pyramid, or they are the most basic trophic level. Then we have the primary consumers. The primary consumers here eat the producers. Next we have the secondary consumers. So secondary consumers eat primary consumers. And then we have the tertiary consumers, which eat the secondary consumers. We can keep going. You can have quaternary consumers. You can even have quintenary consumers. But in this food web, we only have 4 levels: the producers, primary, secondary, and tertiary consumers. Now, one of the things you might notice is that some organisms eat from 2 different levels. So if we look at our funky blue bird here, right, this blue bird is eating from the producer level, so that would make it a primary consumer, but it also eats snails, and it also eats these larvae, which makes it a secondary consumer. If you, for example, are a vegetarian, you're a primary consumer. If you accidentally trip and land face down in a hamburger, then you are a secondary consumer. I think I may have said that wrong. Did I call the vegetarian primary consumers? No, I can't remember. It's late. At any rate, certainly omnivores that eat both meat products and plant products, so like this bird here is an omnivore. It eats plants, but it also eats other animals. Those can sometimes vary in which trophic level they are in. Something like the eagle, which only eats other animals, that's never going to be a primary consumer. That's going to be a secondary consumer or a tertiary consumer. So we can see if it's eating the bird, it's a tertiary consumer. If it's eating the rabbit, it's a secondary consumer. Herbivores, so the ones that only eat plants, those are always primary consumers. You're never going to find a snail lying face down in a hamburger. So things can be in different trophic levels, but then overall, and we're going to see this in our next notes on trophic levels, you can get like an average trophic level. So we can say like tuna, I think, is it's like 4.2, meaning it's basically a quaternary consumer, but it does also sometimes eat even higher up to get that 0.2. So like we could maybe look at this bird, and let's say these are the only things this bird eats. So when it's eating the snail, that would be a secondary consumer. When it's eating this larva, that's a secondary consumer. So we could say 2 plus 2 is 4. When it's eating this plant, it's a primary consumer, so we'll add 1, so 5. 5 divided by 3 is, I don't know, like 1 and 2/5, so that's 1.4. So we could say that this bird's trophic level is 1.4. I don't think I did that math correctly. Again, it's late, but you see how that could work. There's one more type of organism I want to talk about that's not on this food web, but it was just such a perfect food web for our uses, and those are decomposers. Decomposers break down organic matter. Now we're going to talk later in the year about decomposers, and I know some students say like, well, aren't we decomposers because we eat dead things? It's not just eating dead things, it's actually breaking that back down into organic matter, like into soil, into carbon, and it's recycling the energy back into the ecosystem. So that's a decomposer. And you have some decomposers that are scavengers. They kind of happen upon dead things. Then you have decomposers like bacteria and fungus that grow on dead things. So like You know, a lot of people talked about the brown leaf will eventually decompose. Well, it doesn't do that itself. Those are other organisms that are decomposing the brown leaf. I do have some pictures for you of some scavengers that I took a couple summers ago. These were in Connecticut on Long Island Sound. And this one is a dead skate here. I made my daughter move it for me because it was ooey. And then this one is a dead crab. And you can see there's all these weird little round things, right? And they're all there too. Those are snails. So I actually just said you're not going to find a snail face down in some hamburger. These snails actually are face down in some meat. And these guys are scavengers, so they're a different kind of snail than the kind that's hanging out in your yard eating, well, if it's my yard, it's eating my basil plants. So these snails are scavengers, and one of the ways you can look at the health of something like Long Island Sound is by how many scavengers you have around, because obviously the more dead things lying around, the more scavengers it can support. So it was a little questionable as to the health of the sound when we were there, because there were so many scavengers, so many snails. And you can just feel them underfoot, and it's kind of gross. But I said, these are great pictures of scavengers. I have to show them to my students. And what makes them scavengers is that they didn't kill the skate or the crab. They waited until they died and then they ate them, compared to, say, like an eagle that is going to kill its food. So feel free to put any questions you have on YouTube, or you can ask them in class. Have a good night.